Now let's take a look at inverse functions. A lot of students get the concept of inverse and reciprocal kind of confused, or they kind of run together. An inverse is different than the reciprocal. The reciprocal is where you just take a fraction or a number, give it a denominator, and flip it, right? And that's not what an inverse is. An inverse will have this property. If you have two functions, they are inverses of each other if f of g of x is equal to x and g of f of x is equal to x. So two functions are inverses of each other. Let's say the two functions were f and g. If the composition of the two functions both ways is both equal to x. Not both equal to the same thing, that's not what I said. Both equal to x, x to the first power. Okay? So, if you're given two functions, and the question was, are the two functions inverses of each other? Then the way that you can tell is by finding f of g of x and g of f of x. If they're both equal to just x, then they are inverses of each other. Okay? Before I get into an example of that, inverse functions do have a few special properties, and there is some special notation for inverse functions. We've went over domain, how to find the domain of functions, and we haven't went over how to find the range, not directly, but I think you understand that y values or answers, that's the range. And one of the special properties of inverse functions, if two functions are inverses of each other, so given f of x and g of x are inverses, the domain of f of x is equal to the range of g of x, and the domain of g of x is equal to the range of f of x. So it's kind of like, one function, if you think of the domain and range as two different things, which they are, two different sets of numbers, they have opposite domains and range of each other. That's just a special property. I mean, I'm not going to give you a fill-in-the-blank test or anything like that, but just know that the range of one is the domain of the other, and the domain of one is the range of the other. Okay? Also, if functions are inverses, then we can denote the inverse function. So the inverse function can be denoted like this. Okay, and this right here, this is read F inverse. That's not F to the negative 1. Alright, the negative 1 here is not actually a negative 1. I mean, it is a negative 1, but it's not an exponent like you would think whenever you see a number up here. Just one of those little quirky, weird things. And what I'm saying is, F to the negative 1, it's not F to the negative 1 power. It's not equal to 1 over F. It's just a symbol that's put here in the top right hand corner that tells you, hey, this is F inverse. This is the inverse of F. Okay? Now, if you have two functions and you want to know, are the two functions inverses? Or you're told, verify that the two functions are inverses. So we'll do, let's verify the two functions are inverses. Let's say that f of x equals 5x minus 2 and g of x equals x minus 2 all over 5. The way that we verify that those two functions are inverses of each other is by finding f of g of x and g of f of x. What do those both have to be equal to for those to be inverses? What did we say earlier? They both have to just be equal to x. X to the first power. If when we find the composition of the two functions, either one is not just x to the first power, then they're not inverses of each other. Okay? So let's do that. So f of g of x means we take the second letter, so the function g, we're going to take this whole thing right here and we're going to plug it in to f. So we're going to take this whole thing, and right here where we have an x, I'm going to take this whole thing and plug it in right there. So I have 5 times, I'm going to plug in the g. That's x minus 2 over 5. Now what do I have out here on the end? I have minus 2. Alright. So look up here. Here's what I did. I took this term right here, the g, that was the second letter, and I plugged it in right here. And so when you plug something in, put it in parentheses, and then I had this minus 2 right here after it, so I had to put minus 2 down here. So all I've done is I've taken that and plugged it in. Now once you plug that in, now I have 5 times x minus 2 over 5. So since I'm multiplying here, I can cancel this 5 and this 5 out. So that's going to leave me with x minus 2 Alright, this actually needs to be a plus. So, I'm sorry, change this to a plus. So, in your g of x, change that to a plus. I'm just going to change this here. There's a mistype in the book. Alright, I'll blame it on the book. That's how I can get out of it. Anyway, make that a plus there, please. Alright, so same thing though. That doesn't change anything other than this is a plus. So whenever you cancel these 5's out, here and here, that's going to leave you with x plus 2. So x plus 2. And then you have minus 2. Minus 2. Now, these two numbers cancel out and just leave me with x. So f of g of x, that's right here, f of g of x is equal to just x. Now let's find g of f of x. So what that means is the second letter here is f. So we're going to take this f and we're going to plug it in right here in g for every x. Alright, so that's going to be, when I plug that in, that's 5x minus 2, and then I have plus 2 all over 5. Now I can simplify the numerator just a little bit. Right, I have minus 2 plus 2. So what happens there? Those cancel out, right? In my numerator I'm left with 5x. So it's 5x over 5. So now the 5's cancel out and just leave me with x. So f of g of x was equal to x, and g of f of x was equal to x. Now if I wouldn't have changed this to plus, then that wouldn't have happened. If this would have been a minus up here, like I originally had it, then I would not have gotten just x for both of those, and they would not be inverses. Alright? So if it wouldn't have, if the directions wouldn't have been verify the two functions are inverses, it would have been are the two functions inverses, and you don't just get x for either f of g of x or g of f of x. If you don't get x for either one, the first one you work out, you can just stop working there. Okay, and you can say, no, they're not inverses. But I was told they were inverses, so I knew that I must have made a mistake writing it down, and I did. Okay, so I want you to verify that these two functions are inverses. F of x equals 4x minus 7, and g of x equals x plus 7 over 4. So I want you to find f of g of x and g of f of x. Take a few minutes and do that. So here's the way that I always remember which way I need to go. I look at the second letter. That stands for the second function, g, and you plug it into the first function in the composition. So I'm going to take g and I'm going to plug it into f right there. Alright. So I'm going to take g and plug it into f. When I plug something in, make sure you plug it in parentheses. So it's going to be 4 times x plus 7 over 4. And then don't forget this right here, minus 7. Alright, now, since you're multiplying, you can cancel this 4 and the 4 in the denominator out. And I'm going to be left with x plus 7 minus 7. The 7's cancel out, and I'm left with just x. Okay. Now, g of f of x. I need to take the second letter, stands for the function f, and plug it into the g. So, take the f here, f of x, and plug it into the g. So that's going to be 4x minus 7. Then I have plus 7 all over 4. So the 7's cancel out, and I'm left with 4x over 4. Now the 4's cancel out and leave you with just x. So both of these were equal to just x to the first power. So that means that they are inverses of each other. Now I believe there's a homework problem where you have an f of x, a g of x, and an h of x. That just means you have 3 functions. And the question is, which functions are inverses of each other? And so if you have 3 functions and you want to know which functions are inverses of each other, then you're going to need to do f of g of x and g of f of x and see, are they both equal to x? If they are, then they're inverses. If they're not inverses. Then you're going to need to pick f of x and h of x. So that would be f of h of x and h of f of x. Alright? If both of those are equal to x, then they're inverses of each other. If they're not inverses of each other. Then I need to look at g and h. So I'll need to find g of h of x and h of g of x. If they're both equal to x, they're inverses of each other. If not, they're not inverses. That's the only way you can tell if you have 3 functions, which functions are inverses. Now you may work all of those out and none of those be equal to what they're supposed to be equal to. If so, then just none of the functions are inverses. But you do have to try all the combinations. You have to look at f and g, you have to look at f and h, and you have to look at g and h. Just to be like 3 problems within one. Okay. Really 6 problems if you count both compositions, but alright, so that's just, I think there's a homework problem that's like that. There's a very good chance as well that there will be an inverse. It'll say, there'll be a problem that will say, are the two functions inverses? And they won't be, but it still wants you to work it out and show. Okay? And let me show you what I'm talking about. So, because this actually gives students some trouble sometimes because they have to work them out and they get fractions. And let me show you why. Alright. So the question is, are the 2 functions that I'm going to write down inverses of each other? Alright, so 3x plus 7 and let's say g of x equals x minus 7 over, or no, let's make it x minus 3 over 7. If you just looked at them, you would probably say, and you weren't real good with inverses, you could probably just look at them and you'd say, yeah, they're inverses. But if I was to find f of g of x, let's see what that would actually equal to. So you take g and you plug it into F. So I'm going to take this right here, and I'm going to plug it in right here. Well, look what happens when I plug it in. I have 3 times x minus 3 over 7, and then plus 7. In all the other problems we've been working, this denominator right here and what you were multiplying by were the same, so it canceled out. But they aren't the same, so they don't cancel out. So if I wanted to simplify this, I'm going to have to say 3 times both of those. So that's 3x minus 9 over 7 plus 7. There's a couple of ways you could simplify this. One way is to break this up into 2 different terms using term-wise division. This would be 3x over 7, and this would be minus 9 over 7 plus 7. Now that you've done that, these 2 terms right here, this term and this term, are like terms. They're both numbers. It just so happens that one of them is a fraction. Okay? So I need to make 7, I need to change it into sevenths to put these 2 numbers together. I'm going to do that over to the side here. So we know that one number is negative 9 over 7. If I want to change this into sevenths, how do I figure out what's up here? I say 7 times 7, that gives you 49, and that's a positive 49 over 7. If you take 49 and divide by 7, you get 7, so you can check and see that you got that right. So that would be 40 over 7. Okay? So this right here, this is 3/7 x plus 40 over 7. The homework problem wants this answer at the end. Alright, so, or since they have the same denominator, I'm fine with this answer. Just in case your homework doesn't take it, you could get a common denominator of 7 and write this as 3x plus 40 over 7. Now, is that just equal to x? No, that's not just x. Things didn't cancel out like they should have. So the 2 functions are not inverses of each other. But there's a chance the homework is going to want you to work it out and show, it's going to have blanks for these actual answers, so you can see the last answer is not just x. So they are not inverses of each other. Okay. So just be careful. And if you have questions on your homework, you can always email me or ask me at the beginning of class. Alright. So the main thing that we've covered so far is that if 2 functions are inverses of each other, then the composition of the 2 functions, both ways, is going to just be equal to x to the first power. Alright? That, if you have the functions, is the surefire way to tell you, are the 2 functions inverses? Find f of g of x and g of f of x. Okay, if they are both just equal to x to the first power, they are inverses of each other. Now, what if we have a function and we want to find the inverse? Alright, and finding the inverse of a function is not only important for college algebra. I have right now Calculus 2 as well that I'm teaching. They have to find inverses of functions sometimes, and so If I'm teaching how to find the inverse of just a regular algebraic function, I teach it the same in calculus that I teach it in college algebra. All right? You follow 4 steps. Step 1 is to let y equal f of x, or f of x equal y. So if you have the function, and usually if it is a function, it's written f of x equals, you write it y equals instead of f of x equals. We go back to the just regular old equation notation. Okay? Once you have just y equals some x, or y equals whatever, step 2 is to interchange x and y. What that means is, where you have an x, you write a y, and where you have a y, you write an x. So if you have an x squared, it becomes a y squared. If you have a 3x, it becomes a 3y. Where you have a y, you write x to the first power. Okay? Step 3 is the step that usually takes the longest. You need to solve for y. So once you have solved for y, using whatever algebra methods you know, just like solving an equation for y, step 4 is to let, or let's not say let, let's say replace y with f inverse. So instead of writing y equals, we will write f inverse of x equals, because we have found the inverse function. Alright, so let me start off with a really easy example. Let's say that my directions were find the inverse of this function. F of x equals 2x plus 6. And the directions say find the inverse of the given function. So the first thing that we want to do is, instead of f of x equals, we want to write y equals. Okay, so y equals 2x plus 6. Now we got us a good old-fashioned equation. Alright, step 2 is to interchange x and y. That means where you have a y, write an x. Where you have an x, write a y. So x equals 2y plus 6. Step 3 is to solve for y. So do whatever algebra is necessary to get y by itself. Alright, so if I wanted to get this 2y term by itself, I would have to subtract 6 from both sides first. So then I would have 2y equals x minus 6. Now to get y by itself, I need to divide both sides by what? 2. That's right. Now I have y equals. Once you have y to the first power equals, you've solved the equation for y. Step 4 is, now that I've solved for y, I can write f inverse of x equals x minus 6 over 2. So once you solve for y, or get y by itself, then you have the inverse. So what is the inverse of f of x equals 2x plus 6? Or what is the inverse of f? X minus 6 all over 2. Alright. Let's say I had the same directions. Find the inverse. F of x equals, let's say, 9x cubed plus 4. And I want to find the inverse of f. Alright, step 1, write y equals instead of f of x equals. Step 2, interchange x and y. That doesn't mean that you actually move terms over. It's just where you have a y, you write an x, and where you have an x, you write a y. Step 3, solve for y. So the first thing we need to do to solve for y is to get y by itself. So I'm going to get this 9y cubed term by itself. So move this 4 over. So subtract 4 from both sides, and you'll have 9y cubed equals x minus 4. Now, divide both sides by what? 9. Alright, so here's what I have. Y cubed equals x minus 4 over 9. So now, how do I solve for y? How do I make this y to the first power? By taking the cube root of both sides. So with the cube, I took the cube root because I had y cubed. So if I take the cube root of y cubed, I'm just left with y. The right side just becomes the cube root of x minus 4 over 9. So I've solved for y. Step 4 is to write f inverse of x equals the cube root of x minus 4 over 9. That's my answer. Final answer right there. There's a couple of ways I could simplify that, but for what we do, that answer is good. Alright. I'm going to work one more challenging example. Let's say that I had f of x equals 6 over x plus 3. And I want to find the inverse. Okay? So step 1, make this y equals instead of f of x equals. So y equals 6 over x plus 3. Step 2, interchange x and y. So instead of y equals, I'm going to have x equals. So x equals 6 over y plus 3. Now here's where some students will work it one way, some students will work it another. You know, use whatever algebra methods you know how to use to solve for y. Now, me personally, I would probably get this y term by itself. 6 over y, get that by itself. So I'd move the 3 over first. So if I did that, if I moved this positive 3 over and it became a negative 3, I would have 6 over y equals x minus 3. Now, I still haven't solved for y. But what you can do now, since I have this equals this, you could multiply the entire equation by y, and I would have on the left side, I would have just 6. On the right side, instead of multiplying the y times both terms, I'm going to leave the right side of the equation as x minus 3 times y. The reason why I did not multiply it in is because if I multiply it in, then I'm going to have to turn around and just factor it back out to solve for y. So divide both sides by x minus 3 to get y by itself. And you found the inverse. Y equals 6 over x minus 3. The final step, step 4, is to make this f inverse of x equals. Now there are a couple of different ways to get from where I interchanged x and y to y equals 6 over x minus 3. So whatever way you're comfortable with, solve for y that way, as long as you get that answer. All right. Now, does everybody remember the vertical line test? The vertical line test tells you if the graph you're looking at is a function. If you draw a vertical line on a graph and it touches one time, that means that the function that stands for that graph, or the equation that stands for that graph, is a function. Okay? That's the vertical line test. If it touches once, it's a function. If it touches more than once, it's not a function. Okay? Now, the reason why I just reviewed you over the vertical line test is because we have something called the horizontal line test. The horizontal line test does not tell you if a graph represents a function. What it tells you is if you have the graph of a function, then if you draw a horizontal line, it will touch the graph only one time if it has an inverse. It will touch the graph more than once if it does not have an inverse. Okay? So, for example, let's say that this was my function f. And I want to know, does this function f have an inverse? The horizontal line test says draw a horizontal line. If it touches the graph once, it has an inverse. If it touches the graph more than once, it does not have an inverse. So if this problem asks me, does the function represented by the blue line have an inverse, what would the answer be? Yes, it only touched one time. So the function does have an inverse. That one does. Alright. Let's look at another example. What if I was given this graph? This is y equals x squared, or something of that nature. If I draw a horizontal line to find out, does this function have an inverse? How many times does that touch? More than once. It touches twice. So what that means is, does this line have an inverse? Or does this graph have an inverse? No, it doesn't. So, does this have an inverse? Yes, it only touches once. Does this have an inverse? No, it touches more than once. You may be thinking, well, why doesn't it have an inverse? Y equals x squared seems like you could solve pretty easy. You could change the variables and solve. But remember, when you take the square root of both sides, you have to put a plus or minus in front. And so that means it doesn't have an inverse, if you're just thinking about the equation. Alright. But the horizontal line test, you don't have the equation, you just have the graph. And you draw a horizontal line. If it touches once, then the function has an inverse. If it touches more than once, the function does not have an inverse.